MOUs with ONGC for proving up pore spaces in depleted oil and gas fields or saline aquifers for CO2 sequestration, CO2 EOR, and for possible CCS hubs in West India. Prior to joining Shell, he worked with BG Group as the technical director for BG Asia Pacific Limited, based in Bangkok, and as director for projects and operations for BG Exploration and Production India Limited, based in Mumbai. Mr. Baroruchi is also an author, published Rhythm of Life, a poetic rendition of the Bhagavad Gita. He's a member on the board of Living Peace Projects, a not-for-profit organization based in the Netherlands, which spreads awareness and builds rainwater harvesting and sanitation structures in India. Mr. Baroruchi Mishra, I'd like to kindly invite you on stage. Thank you. Round of applause. Our first panelist for the day is Mr. Sanjeev Gupta, Executive Director, Corporate Strategy, IndianOil Corporation. Mr. Sanjeev Gupta is an Executive Director, ED, and Head of Corporate Strategy at IndianOil Corporation Limited, India's largest state-owned oil and gas company. He's a seasoned professional with over 35 years of experience in the oil and gas industry, with a focus on corporate strategy, business development, and marketing. Mr. Gupta has held various senior positions at IndianOil, including Head of Marketing Planning and Research, Head of International Business Development, and Head of Corporate Planning. He has played a key role in shaping IndianOil's strategic direction and driving its growth in recent years. Under his leadership, IndianOil has expanded its international presence, diversified its business portfolio, and strengthened its brand position. Mr. Gupta has also been instrumental in developing and implementing IndianOil's sustainable strategy. Mr. Gupta is a highly respected figure in the Indian oil and gas industry. He's known for his strategic thinking, his business acumen, and his commitment to innovation. He's also a strong advocate for diversity and inclusion in the workplace. I now request Mr. Sanjeev Gupta to kindly grace the stage, please. Thank you. Big round of applause. Our next panelist is Mr. Narinder Goyal, President, New Initiatives and Ammonia, Avaada. Mr. Narinder Goyal, a chemical engineer and postgraduate in finance, heads green ammonia business at Avaada Energy Private Limited, India. A specialist in project management and plant operations, his 3 decades of experience in nitrogenous fertilizer sector entails successful implementation of mega projects, strategic planning, cross-functional team building, sustained plant operations, and ESG performance. 2200 MTPD blue ammonia plant, built and commissioned under his leadership in Jan 2019, is among the licensor's showcased plants and the most efficient as of today. He played a significant role in achieving sustainable plant operations continuously for 2 years, thus cutting down the production energy losses due to undesired shutdowns. He's a key speaker on various topics, including ammonia technologies, effective project management India as next manufacturing hub, and clean fuel technologies to achieve decarbonization. He has globally traveled across the process industry, licensors' engineering offices, and equipment manufacturers' facilities, and is a known face among the ammonia industry. He is currently working on development and implementation of green hydrogen and green ammonia projects for Avaada Group. I now request Mr. Narinder Goyal to kindly grace the stage. Thank you. Round of applause. Over to you, sir. Thank you.
Do we have a mic or? Okay, let me first talk from here and then I'll keep the mic. So we are standing between lunch and you. So we will be short. We have a 50 minutes panel discussion, but we do hope to make it interesting and engaging. So let me start with this, the conference itself. There is this Rigvedic shlok which says, Ano Bhadra Kratavo Yantu Vishwataha Abhadhasho Aparitas Udivdha. Let noble thoughts come to you from all directions. Abhadhaso, unbeguiling, undeceitful, truthful. Aparitas, uninterrupted, in a continuous flow. And udivdha, which is for the benefit of every being. So that really is the intent of this conference, or really the intent of getting together. It helps us to stay in the question, to share ideas, but more importantly also to get some insights on how to convert these ideas into actions. Because the real virtue, as they say, wisdom lies in knowing what to do, skill lies in knowing how to do it, but the real virtue lies in actually doing it. So we are here today to try and take some insights from leaders who are on the dais and from all of you to try and understand how we get into this very existential crisis that we are facing and how to solve it. Now, this is starting with the premise that we do believe that global warming is for real, that CO2 is creating havoc. A sense check of where we are now would be very important, and that might imbibe some of the thinking around why it is urgent to start. The best time to plant a tree was 50 years ago or 10 years ago, but if not done, now is the time. Let's figure out why. So to get to 2 degrees centigrade, there is a carbon budget of roughly 3.9 trillion tons. And to get to 1.5 degrees centigrade above pre-industrial levels, which was 1850 to 1900, it is 2.9 million tons, or 2.8 trillion tons. Where we are today is 2.4 trillion tons. Our budget is only $500 billion to get to 1.5. So for all practical purposes, 1.5 trillion is already, 1.5 degrees centigrade is already baked in. In fact, Copernicus came out with data which says 2023 was the hottest period in centuries, and 2024 is going to be the worst. Practically, what it means for India, and then we will start the conversation, is this. When the wet bulb temperature gets to 35 degrees centigrade, the sweat does not evaporate. The perspiration does not evaporate. What that means is the cooling mechanism that the body has is lost. So what does the body do then? The body, in its desperation, dilates the blood vessels to reduce the temperature, higher flow, reduce the temperature. And in doing so, in dilating the blood vessels so much, the blood doesn't get to the brain, and all our functions, the bodily functions, start shutting down. And then you have heat waves causing deaths. In India, there have been places in Mangalore and other places where the wet bulb temperature has hit 34 plus. So we may be like an ostrich buried with our head in the sand saying nothing is going to happen to us. The fact remains that we are all facing an existential threat, and it is no more about which country is emitting CO2 or which country is not. All the historical wrongs of the Westerners does not justify another wrong for us. So we have to hasten our energy transition. So the trilemma is this. So we have energy security, we have energy access or energy equity, and energy sustainability. Let us start with energy equity. This trilemma we have to solve. So what is energy equity or energy access? So come to think of it, our human development index is 0.6 or 0.5, which is in the lower quartile. If you get to average, we will be around 1, and that would be roughly tripling or 4 times our energy consumption of 6,000 odd terawatt hours per year. It should get to 28,000 terawatts per year. So we will need energy. Let's figure out how we will get to that in this panel discussion. Your own thoughts, please feel free to interact, give us your views. And it is not about pulling wool over anybody's eyes. It is so for real, and this is the right time because it will help us stay in the question and do something about it going forward. So I'm going back, and then I'll invite my esteemed guests, panel members, and you know them. They have already been introduced. So let me go back and start talking from there. All right, so let me start with Mr. Gupta. The tremendous experience of having led strategy for IOCL, and is an industry veteran, and he's been sleeping and breathing, dreaming about energy transition. So Mr. Gupta, tell us, how is the transition in India going to be different from the rest of the world? What are your thoughts on it?
So thank you, Mr. Mishra. I think in terms of building blocks, they are not very different, be it India or abroad. But the one fundamental difference is that most of the places, be it West OECD countries, most of them is the one energy versus another energy. Because in terms of their energy consumption, they are already plateauing. There's hardly any growth. Whereas in India, the difference is that we are growing at a very fast rate. Last, I think, 2022 was exceptional, 6.5 to 7% we grew in terms of energy consumption. This year also is very high, and on an average 3.5 to 4% we are growing. So the one basic difference comes is that it is not energy versus energy in India. Essentially, our appetite for energy would accommodate all kinds of energies. So in terms of investment in renewable power, India is adding on one of the biggest in the world. In terms of biofuel, we are adding on. In terms of oil and gas, we are adding on. In terms of hydrogen, we are adding on, so is the e-mobility. So in terms of all these energies, they are welcome. Now, the basic challenge, both from India's perspective and IndianOil's perspective, is that Europe probably, which always took energy access, energy security for granted, first time jolted out. And they felt that they cannot overlook energy in terms of security. Too much dependence on one geography was very difficult for them to handle, both in terms of their growth and making their industries also very competitive because of the kind of price increase which happened. Fortunately, because of the government of India's policy, a normal consumer in India didn't face that kind of challenges. So from that perspective, if I look at it, both oil sector in India, we are investing in the traditional energies. So IndianOil is investing, not only IndianOil, all the oil companies are investing in core business, which is our oil refining, number one. We are expanding our market infrastructure, and we are also investing in gas infrastructure because we believe that for the times to come, these core business areas would remain part and parcel, which is required. In no way we can reduce or we can play with our energy security. But mindful of this aspect that all these are carbon intensive sources of energy, we are equally taking steps at national level in terms of all other energies. So if I look at it from that perspective, Indian oil and gas companies, and one more point I like to share, that unless oil companies don't take these steps, no other industry can change it. The kind of technological bandwidth they have, kind of financial muscles they have, nobody else can do that. So we all are mindful of that. So from that perspective, just to conclude my answer, that India's journey is much more holistic, much more expanded, and as a country will continue to invest in all kind of energies, and which will take care both energy transition as well as energy security.
Thank you, Mr. Gupta. That was very comprehensive. So essentially, we're saying that it is an and solution for India. We will need oil and gas, but we also have to be very actively investing in the renewables. And the speed with which we have grown in 2022 is 6 to 7%, and it is continuing to grow. Europe, etc., coming to a realization that they can't rely on energy security from one geography, but for India, the government has been taking a lot of actions to manage, at least to keep the pump prices within limits in a way. So that's good. But one key thing that you said was it is incumbent upon the oil and gas sector to make the first start. Why? Because they have the financial muscle. They are in it. They understand the ecosystem. So it's very important and they have the technology. So it's important that the oil and gas sector takes the first step and hastens the process. Thank you, Mr. Gupta. We'll come back to you, sir, once again. So my next question is to Mr. Goyal. Mr. Goyal is a veteran in ammonia. He's built a lot of plants, et cetera, in ammonia. And there are multiple pathways for getting to net zero. And ammonia is one of the key things that we talk about. So, Mr. Goyal, the question for you is, should we treat ammonia as a hydrogen vector or a fuel in its own right? In its own right. What are your views on it?
Thank you, Mr. Mishra. Thank you. I'm audible, sir? I'm audible? Okay, thank you. So, Mr. Mishra, you rightly said, actually, hydrogen is the sought-after molecule as an energy transition, as a next-gen fuel, as a clean fuel. The entire world community, including India, we require hydrogen as a source of fuel, not ammonia. But hydrogen transportation have its own challenges. Its liquefaction is minus 180 degree temperature, rather more than minus 200 degree temperature. That consumes lot of energy, which makes it unviable as a fuel. So the next closest molecule as a mode of transportation is ammonia. Ammonia can be manufactured easily. It's a proven technology. And all are here from the industry. You must be aware, but I'm repeating for the sake of this discussion. India is the third largest manufacturer of liquid ammonia in the world. As we all know, our economy is agrarian, and we need a lot of nitrogenous fertilizers, and we are the second largest consumer as well. So there is a net import of ammonia as a chemical. So Indian ports are well equipped to handle ammonia, even if it is amounting to dispatch. So we have as I was mentioning during a question answer session with Mr. Sharma, India has a historic opportunity to be an energy exporter. We can make ammonia. For making ammonia, we have all the required material and skill set in India. As I said, we are the third largest manufacturer. We have a large pool of experts. In fact, the entire Middle East ammonia industry is being operated by Indians. It's not wrong if I say that. We have a lot of sunshine here. Renewable energy can support such a molecule manufacturing. Of course, we don't have wind as much as European countries have. But on the same time, we all in the industry are working towards alternate energy storage systems like pump storage. So in the daytime, we can pump water from lower reservoir to upper reservoir. These are the off-stream pump storages. So in the night when there is no solar, we can run the turbine to generate power. So it's efficient. It's as efficient as any other energy storage system. Rather, for this route, we don't need to depend on any external source of energy storage. Like if battery energy storage systems, let's talk of. So it will be requiring the material which we don't produce domestically. So we as a ammonia industry want to give a solution which is more domestically created, and we can make that molecule at a cost competitive price which can sustain and compete with blue ammonia in the international market in coming years. And in totality, we should be exporting to the geographies like Japan, Korea and European Union where they need lot of it. Thank you very much. I think I could clarify that ammonia is a carrier of hydrogen, not itself a fuel.
So thank you, Mr. Goyal. Very insightful. Essentially, what is heartening to note is the ecosystem for ammonia is completely developed in India, and in fact, India is driving a lot of expertise for the Middle East and manufacturing, etc. So that's good news, and you very well clarified that it's a hydrogen vector. It is not as a fuel, cannot be used as a fuel by itself. But one thing that we need to talk about a little bit is just the hydrogen economy. Let's do some maths. So $2 per kilo of hydrogen corresponds to $15 per MMBTU of LNG. Now, Goyal, I don't know what is the price they import the LNG at, but long-term contracts are $7, $8, $9, $10 or whatever. So even at $2 per kg of hydrogen, we will not be able to usher in into a hydrogen economy because it will still stay unviable, or the purchasing power will not be there. So we have to get to $1 per kg of hydrogen. That's a very tall order. The capex for the electrolyzers could be 20 to 30%. It's a PEM electrolyzer or alkaline electrolyzer or solid state electrolyzer, whatever, solid oxide. 60%, 50 to 60% is electricity itself, renewables, and then the remaining is OPEX. So really 10%, 15% is the OPEX. So what we are therefore talking about is a hydrogen economy which today becomes almost unviable unless you have two things: the purchasing power of the people increases and the government gives subsidies, or we bring down the renewable energy cost to nearly free. Only then you can talk about a $1 per kg of hydrogen, which equivalent to $7 per MMBTU for LNG. It's a tall order, but that's something that we will need to understand. Yeah, please say. And yeah, in that context, how does ammonia fare?
Yeah, I think it is very important to elaborate the insight here. I'm sorry to say, being an Indian, I'm still saying that as a community, we resist change. And that is naturally understood because we never saw the surplus of anything. We always lived a life where the scarcity was the key word. We were talking of water scarcity, we were talking of food scarcity in the 60s and something. And I think when we decide as a community that this is the area to be dealt with, and we could. Yeah. In 60s, we could handle the green revolution to feed our people. And in 90s, when external countries did not support our cryogenic engine, I'm very glad to inform that our scientists as ISRO and Vikram Sarabhai Space Center, they all developed those engines. And coming back to this, I will remind you 2006 or 7 when solar power used to cost 17 rupees a unit. Yeah. And why it was used? Because government made it mandatory to be used. There was a RPO. For all the industries, 30% of their power need has to be supported by renewable energy. That was the mandate. There were many litigations. I was part of one of that because fertilizer industry resisted that change. But as the country moved forward with a lot of renewable energy, today the cost is 2.3 rupees, 2.5 rupees. And I feel glad when I meet counterparts from Spain and other European geographies, and they ask us, we want to learn how India could manage to reduce the cost that much, which no other country could. And one more fact, maybe some of you may be aware, that India is the only geography in world which is having national grid. And Ministry of Power and Renewable Energy is coming up with a resolution that India will be treated as one territory. So no other country is having such a large grid of 300 gigawatt, which is continuously expanding further. You all must be aware there are already the augmentation happening. Now coming back to the numbers which you said. So why I said this, as a community we resist change, when government proposes that Indian fertilizer industry, who is importing 2 million ton of ammonia right now, government has issued an advisory to replace that ammonia with green ammonia. Instead of evaluating as an option to sustainable future, the industry comes up with a reply that it is technically not feasible. Because they will cite that they need carbon dioxide to make urea, so that is why they need SMR route of making blue ammonia. But I just leave a thought here before I go into numbers with Mr. Mishra wanted to know. I wanted to answer why $1. So I just leave a thought here. Consider NTPC operates coal-based power plants, and we need a lot of them. It was disheartening when I saw a screen here. Dr. Sharma was telling thermal power has to be reduced. No, it is not sustainable. Our energy requirements are ever increasing as a growing economy. We should sustain our coal-based power plants because coal is domestically available, of course, of a little higher ash content. But if coal-based plants continue to generate power and I capture carbon and I make ammonia through the green route and make urea for the purpose of that, so I'm helping the coal-based power also to decarbonize. But we as a country, we as a technical people won't work on the options which are challenging. We will keep on working the options which are provides more comfort. So that is the part we need to challenge. Of course, the bright spark is there. The younger generation is very, very aggressive, and they don't really want to live up to their past. They want to challenge the old practices and go for the new practices. That is the bright spot in the whole story. Coming back to numbers, you said $1. I say why $1 first. Second, the renewable energy is already the lowest in world in India, 2.5, say even $3 I take, 3 rupees I take. I need 55 units to make 1 kg of hydrogen. That means I'm close to $2 as a variable cost only. I'm not talking of capex. But if as a country, if as an economy, we start using, we move the way forward, which is mandatory. Otherwise, this planet is not sustainable. Our lives may be, many of us may be 20 years, 30 years, 40 years more. But what about the planet's life, which has to support mankind for thousands of years? What we are leaving behind, that is to be thought of.
Yeah.
So there is no option than to replace carbon emitting sources with clean fuels.
Yeah.
Come what is the cost. If we will move forward, I'm sure as we demonstrated that renewable energy cost could come down from 17 rupees a unit to 2.5 rupees a unit. Same way hydrogen cost I'm sure will come down. Just a number here, electrolyzer cost was $400, $500 a kilowatt just a year ago when I came to this industry, and the last national tender in China, which was opened last week, has given the cost of $195 a kilowatt. So it's already down by 3/4 times. So there is a reduction in the cost in capex. As we will continue to support this economy, the prices are bound to happen. Why even $1? I will target to reduce the cost of hydrogen even lesser than that.
Very good. So the Baofeng project in China achieved $2.76 per kilowatt. In India, for the PEM electrolyzer, we are in the range of $1,000 to $1,100 per kilowatt. Alkaline is more in the range of $600 to $700 per kilowatt. It's a great thing. As I said, we have to all change. Old order changeth, yielding place to new, and God fulfills himself in many ways, lest one good custom should corrupt the world. And that custom was emission of CO2 without being mindful of what's going to happen to the world. And that custom is changing. Let me come back to, thank you, sir. Let me come back to Mr. Gupta. So, sir, I'll be a bit specific now. Could you talk to us about, we heard ma'am talk a lot of stuff that she was talking about on the energy transition things that are happening in Oil India, but from your perspective, what is the overarching theme, as in which direction is Oil India going in, and what steps are you taking as the first mover? Because FOAK, first of a kind, to NOAK, nth of a kind, there is always a cost reduction. There's always a risk reduction. There's always a market maturity. There is always a technological evolution. And you guys, being the first ones, are leading that path. So why don't you tell us a little bit about it?
So when we started this journey of energy transition, there were a lot of internal debate. And being hardcore oil and gas company, like mostly the way we look at it, we felt it's going to take decades before we should even look at it. And a lot of internal debate, should we not? But what emerged out eventually after a lot of deliberation that in terms of any research, the biggest challenge is the timing. So nobody can say whether it will be 5 years, when it's going to become a very big source, be it e-mobility or for that matter hydrogen or biofuel, or would it be 15 years from now when they are going to become predominant sources of energy. So what eventually emerged out, in which Indian Oil management agreed that this is the time, one, is to identify right technologies. Second, this is the time to find the right partners. And third, this is the time when we should build a skill set within company. So once three of these things are there, scaling up anyhow is never an issue for a oil company like Indian Oil. Day in, day out, we can scale up any business the day we want. But if we decide not to do anything now, when one of or all of these energies become very important, probably that time would be too late to identify right technology, right partners, and build a skill set within company. So keeping that in mind, very unlikely for a public sector, in 2017 we invested in a US-based company called LanzaTech. Now, LanzaTech company is the one which converts carbon dioxide, carbon monoxide through microbes into ethanol, and now building blocks for petrochemical, which are unthinkable in a public sector. On a very lighter note, when I was defending just maybe $20–25 million investment, in oil companies, $20 million, nobody bothers. Because our budget is $5 billion in a year, nobody bothers this. But it took 2 hours to convince our board that we should invest in a company. That also in the context of a private company. So that's how our journey started. And we realized that biofuels, both 2G and 3G, would be a very important part. And that way I'm talking about 2017. Of course, later government make it a very big force when it comes to all our targets were preponed in terms of ethanol, 20% from 2030 came to 2025. And very fast, because I remember it used to be 1%, 1.5%. So difficult to procure ethanol. Policy were changed, government supported, and today 12–13% pan-India ethanol blending we already achieved. So that's the one thing. Same challenge was there in some of biodiesel also. Today also it's a challenge, and globally it's a challenge, biodiesel, because particularly one major source is UCO, and UCO, all sudden in India is still a very unregulated market. But we start making foray in 2G ethanol, 2G for that matter biodiesel also. And 3G ethanol, based on LanzaTech, we invested almost 800 crore rupees in Panipat. And please understand, it's a new technology. Yet company committing 800 crores is not a small amount. So that kind of decisive step we started taking. Coming back to e-mobility, 2018 we started evaluating what would be the right technology when it comes to battery for India. And we were aware that for oil we are dependent on import, gas we are dependent on import, and if we start depending now for all raw material for battery also on import, then eventually it's oil which is shifting to another source of energy. But one thing we realized that the oil and gas one, many of the geographies are common, some are different. Their pricing cycle also are different. So though dependence is there, but yet pricing cycle is different. So keeping that in mind, we identified and we mapped all technologies available for battery, and we finally enter into agreement with an Israel-based company called Fee Energy, which is into aluminum air. And why aluminum air? One, that is the metal layer technology, which is almost 3 times of the energy density vis-a-vis lithium ion. Number two, aluminum is abundantly available in India. So we realized that this is the one technology. We invested and we formed a joint venture. Then subsequently, we also started investing heavily into building the infrastructure when it comes to e-mobility. So 2 things we did. One, we started supporting Government of India's own intent to have charging infrastructure on our retail outlet. And if oil companies, I go back to my first answer, that if oil companies decide to support any initiative of government, nobody else can do better than that. Put together, 3 of the oil companies alone have more than 1.25 lakhs of sites. And they are prominently placed sites. And this is a sunk cost for us. If anyone, a new player wants to set up, the land price will be prohibitive. And he can't make any money out of charging infrastructure. But for us, it's a sunk cost. We also realized that charging at our retail outlet with oil and gas still being the major bread earners for us would not be very easy. So we started looking at an alternative model, and we realized that battery swapping can be a very good solution with battery charging. And then based on our due diligence, we sought board's approval, and we are forming a joint venture with a bank. It's a Singapore-based company called Sun Mobility, which are into battery swapping, and IndianOil management has approved almost investing $500 million in next 3-4 years in battery swapping. So battery charging, battery swapping, biofuels. Now we are also working on identifying cell manufacturing in India. So eventually what I'm coming to, that from oil companies' perspective, and specifically IndianOil, we are expanding our refineries, expanding our infrastructure when it comes to LNG import, 2G ethanol, 3G ethanol, biofuel, charging infrastructure, battery technologies, and lastly, we formed a joint venture when it comes to hydrogen with L&T and Renew Power. And because today also hydrogen price is extremely high. People are talking about $1, but people are talking $1 2 years back also. We don't know when this $1 will be achieved. Coming back to today, the grey hydrogen, probably the kind of experience oil companies has, no one has. Half of the India's consumption only oil companies are doing. We know how to handle hydrogen, particularly grey hydrogen. Grey hydrogen price is extremely low. Anytime, if I look at it, it can be less than $1 or maybe $1.5, not more than that. So it will be tall order before green hydrogen will come. But same point which I talked about, we don't know the timing. So IndianOil has formed joint venture. We are going ahead. So just to summarize, oil company, particularly IndianOil, we are going into all possible forms of energy. And as I said, scaling up would be much easier whenever we want to do so. Thank you.
Very comprehensive, sir, and thank you for that. Essentially, what you're saying is you are not shy of making partnerships. You are also not shy of investing in technologies which are still not proven, maybe at TRL 6-7, so long as you see that this is going to be the future. And LanzaTech investment has really given you that confidence, and many other partnerships that you're doing. That is the name of the game actually in energy transition, collaboration. If you look at, so let's put it this way. Except wind and solar, all other pathways for energy transition are not in the money. they are either banking on subsidies or are not counting some costs, which are sunk cost, for example, and stuff like that. So really, the only companies which can really move forward or to show the light then to reduce the cost over a long-term period of operation are the oil and gas sector. So thank you, that's a great insight. I'll ask one more question and then we'll go back to the audience. And this question is for you, sir. So Indian government has talked a lot about hydrogen policies and all of that. Not the same amount of visibility about ammonia policy, or at least we are not clear of it. So in 2 minutes, can you tell us what is the government's thinking on it? Because we already have a very strong ecosystem for ammonia. How do we get to green ammonia and then use as a hydrogen vector to export? In 2 minutes, can you please give us a view?
Okay, thank you, Mr. Mishra. In fact, Ministry of Renewable Power and Renewable Energy, New Renewable Energies, MNRE, which is the nodal agency for green hydrogen mission, is already promoting green ammonia projects. And as a part of their first effort, they are now going to issue a tender for aggregation of 2 million ton of green ammonia produced domestically. So instead of bringing a law or policies, they issued advisory, as I mentioned, to fertilizer industry to at least start replacing the imported ammonia with green ammonia. That is at advisory level. And I hope after this general election, there can be the obligation as well. So already nodal agency is working to bring in green ammonia as a potential fuel. But my suggestion here is that if 2 million ton of green ammonia which we are importing is replaced with green for making phosphatic fertilizers largely, will not be bringing in much of the capex impact on the industry. Okay. It can be absorbed very well. And the second, I think ministry is already working with the shipping ministry to bring in some regulations for use of ammonia for marine industry as a fuel, because IHI Japan has already developed a 2 megawatt gas turbine which is purely on ammonia as a fuel, and they are deputing that gas turbine engine along with GE for making the tugboats. So tugboats can be the starting point for use of ammonia as a fuel.
Thank you very much, sir. That is very enlightening. So therefore, ammonia as a fuel is also coming up, but at a slow pace. Thank you. Very good. Hey, so we'll go back to the, we'll come to the audience. Keep it short. Speak to the agenda. Your views and opinions of life can always be there, but let's speak to the agenda at hand. So who's got the mic? Somebody circulate the mic. Oh, you have the mic. I start loving my voice when I talk. Please don't do the same.
You know, narcissism is infectious.
All right.
Anyway, coming to the issue of your ammonia, you are very right, it's a vector for hydrogen, but Mr. Goyal raised an issue, substituting the ammonia in the fertilizer sector as a priority. Now, I have some background because I have been setting up 3 urea power stations as part of the FURL. Mr. Sanjeev Singh, who is now in IndianOil, he was chairman, I was the vice chairman for 4 years. Coming to the issue that economics as it works, the ammonia is a basic input, it goes into the carbamide production and all the way to the Prillingtor and urea production. All the projects as of now have the ammonia production unit by the existing process as a sunk cost. And the ammonia, green ammonia, which is going to be brought, is going to be very costly as of now because it's a hydrogen vector, as we all know. How is it going to impact the urea cost? Because it's already subsidized by the government in a big way. Point number 1. Point number 2, should I target that urea plant and fertilizer plant for substitution of grey ammonia or black ammonia by green, or should we target the steel industries and others who are going to face CBAM and other export restrictions from 2026 onwards in European market? 2 questions.
Okay. Would you like to take it? Yeah. Thank you.
Thank you, sir. Your first question, how green ammonia usage will impact urea cost. I mentioned in my inputs that I'm proposing not for urea to start with till the costs are high, because urea manufacturing requires 1 mole of ammonia and 2 moles of carbon dioxide. So that carbon dioxide has to come from the location within the project site. So typically Indian industry and worldwide all are making SMR route, capturing CO2 and transferring to urea plant for making CO2. Here I suggested that NTPC or coal-based stacks can provide CO2 and ammonia can come from the electrolysis route to make ammonia. So cost apart, this can be the second step. I propose that ammonia which is being imported and used for making phosphatic fertilizers where CO2 is not the content. So there we can start replacing this green ammonia. If 2 million ton of green ammonia is used annually, about 4 to 5 projects of large scale will be operational in India, and certainly that pathway will bring the cost down further also and will give the experience and learning on this new eco space. This is first, sir. So urea cost is not the first step, otherwise it will got impacted, of course. But as you know, phosphatics are not subsidized, so that there is the potential, or there is a budget for green hydrogen mission. There, if 2 million ton and about $300 per ton of ammonia is the cost difference today between gray and green. So 300 into 2 million, I think 5,000 crore odd rupees. That is not a big amount as far as the budget allocations for green hydrogen mission is there. And your second question, can I request you to? Okay, so I hear Hardeep Puri sir in various discussions, he always promote domestic market. But whereas as an industry, we are more focused right now for export. All the projects we are planning on the port cities so that the export can happen. Right now, every molecule which is being planned by project developers, including my company, is primarily to be exported to Japan, Korea, and the European Union.
Yep. Thank you. Any other question? Yes, it's an opinion or a question? Oh yeah, please go ahead. Mike, please, can you give him the mic? Okay. I'll give you the mic.
So 1 second.
Mr. Goyal, most of the ammonia which is imported is basically used for phosphatic fertilizer, which I know.
Sir,
not for urea. So why switching to green ammonia is reluctance? Because now also there is no positive movement by phosphatic fertilizer manufacturer to start going towards using green ammonia. Mainly cost factor, but then how it will be overcome and how we can promote use of green ammonia instead of importing.
No, Mr. Parikh, my suggestion is in terms of decarbonization only. And right now, this fertilizer, India is not exporting anyhow. So CBAM doesn't come into picture because we are not the exporter and exports are not permitted from India as well. So we are the net importer. Why we are importing ammonia which is having a carbon molecule attached to it? We should be making our ammonia here which is carbon neutral. That is my suggestion. Numbers are apart, we can discuss offline. Yeah. I can suggest the ways to reduce and optimize the numbers.
Excellent. Thank you very much, sir. His domain expertise is available to you after this, and please discuss with him. Yes, there's a hand which is going up. Yes.
Question to Mr. Gupta. Yeah. You talked about 2G, 3G as well as e-mobility and all. But any IOC, any plan for green hydrogen as of now?
The major consumption when it comes to green hydrogen in India would essentially come from refining companies. As I said, half of the hydrogen used, grey hydrogen, in refining. And all the oil companies are going ahead. So far, there is no GSCO, green hydrogen consumption obligation from Government of India, because it has direct implication in terms of the, somebody has to bear the cost, and that's a huge difference. But oil companies on their own are going ahead. And I think very soon, number of companies, including Indian Oil, would be announcing their own projects, and that what will be done within this year.
Okay. Thank you. Thank you very much.
Just on the hydrogen, so we lost, if I may use the word, the battle to China on solar, meaning the solar cells. But a Rystad report says that out of the 40 to 45 gigawatts of electrolyzer manufacturing capacity which has taken FID, roughly 1/4 or slightly higher is in India, around 10 to 12 gigawatts if you count the Adanis and the Reliances of the world. Ohmium, which is a company incorporated in Arizona, is it? Or they have a center of manufacturing excellence in Bangalore where they are going from 0.5 to 2 gigawatts. The reason for this is very simple. Our steel indices are nearly the same as China. We're 10% lower for structural steel, higher for structural steel, cold roll coils, hot roll coils, etc. In 2019, we were lower than China in our steel indices. Our labor cost is half or 2/3 of China. Our engineering cost is half of China. So all the resources, yes, you have 3 to 4% of rare earth metals, iridium and all of that in PEM, etc. But given the technology speed with which it is moving, there is no reason why in India we could not lead this space of global manufacturing of electrolyzers. And that's the bright light for all of us. And as you said, we can get it to a number which could be still lower than $1 per kg. One question, yeah, please.
Hi, thank you very much. Very excellent inputs that we have got. The point is, I think the focus seems to be getting down from $4 a kg, $4 a kg to $1 a kg of hydrogen. So what are the areas of, innovations that are required to bring down to this level? Is it electrolyzer material, or is it a long duration storage of the battery storage? Again, that comes to the material part. And thirdly, the quality of the water. Probably with the brackish water, it's for just high quality, super quality water that is required for electrolyzers and so on. Are there any other areas, or what kind of developments are going on in the world and in India to get to these levels? I think that seems to be the most important question. Just one comment, if you don't mind, is I believe green ammonia, anything green, stops at green ammonia. Because I understand when you use to give urea, so-called green urea, it is no more a green because the way we sort of use the fertilizer, a lot of the carbon dioxide gets evolved from the soil. So carbon dioxide gets back to the atmosphere. So it's not a really green urea. So as you said rightly, for phosphatic fertilizers and others, green ammonia is excellent. And also transportation to use as a fuel in furnaces. Thank you.
Excellent. So thank you very much. Your question is same. Mishra ji just put the nail in right place. Electrolyzers is the key word here. We as a country, we as a technologist have to move forward to innovate on electrolyzers. There is no reason India can make electrolyzer which is more efficient, less costly than any other economy or any other country can provide today. You asked me the reasons how we can move from $3 or $4 to $1. See, power, renewable energy is not going to reduce much drastically because it's already at quite low price in India. But round the clock energy is the one number which is the game changer here. So I mentioned indirectly in my various inputs that pump storage is the another way of energy storage. In India, our natural terrain is in such a way that if 10-meter head is available on the river side or on the hilly side, so that can be used without much capex. So that is one. Second is the electrolyzer efficiency. Today, almost all the alkaline electrolyzers are consuming close to 52 to 53 units a kg. So hypothetically, it should be 39 stoichiometrically. So we all have to work together to bring down the electrolyzer cost as well as improve the efficiency. That is the key here. Yeah. Thank you very much.
And just so all these people, so my companies like Shell and others, when they get into an MOU with electrolyzer manufacturers, because they have to book capacity, the capacity today is roughly 1/8 or 1/7 of what is actually required. So everybody is in a rush to book capacity. When they book capacity, what they also do is they create an opportunity register. What are the pathways for reducing costs? So for example, for PEM electrolyzers, you could have reducing the iridium loading, increasing the current density, and reducing the footprint, bringing in as much as BOPs into their containers, balance of plants, reducing the footprint of the demineralization, mineralization for water, etc. So all that opportunity register is created, and then it gets into a level of de-risking and figuring out lab analysis, etc. But this is an area where we can really break from the norm. If you hear Mr. Anil Kakodkar, who was the ex-chairman of the Atomic Energy Commission, he said, your answer to less than $1 per kg of hydrogen is radiolysis. So break water using radio waves. So there could be many technologies which can come up, but really this is an area where we can really go. Innovation is key to that. Thank you. Any last question? I'll take time's up. Last question.
Yeah, so my question is to Mr. Gupta. As you rightly said that oil companies have to take the first step in decarbonization, and as they have the financial muscle. But do you also think that not just taking care of the scope 1 emission, but the oil companies, owing to their financial muscle, should help other players in the value chain to decarbonize too? Like maybe helping someone else with subsidy or money, or investing a chunk of your profits in technologies that will help reduce carbon emission in the near future?
I think if I look at all three scopes, then we become completely responsible for the entire India's carbon footprints. So it's a gradual process. What IndianOil also has announced that by 2046, our operational these carbon footprint will take care of it. So scope 1 and scope 2 takes care. And it comes to scope 3, which is very large. And please understand that when we are going for scope 1 and scope 2, there are a number of companies who become our partner. And through that process, we are supporting. Most of the strategic alliances we have done, they are very small companies. And those small companies we are supporting when we are investing either as equity or when we are forming joint venture. So I think it goes without saying that all the oil companies, we don't have all these technologies, and many of these technologies are the startup system through which we are getting. We are supporting that way. I hope I am able to answer to some extent.
Yeah, thank you.
All right, ladies and gentlemen, the time is up, and thank you for your participation. I will leave you with one somber thought. And this is without any offense being met to people who are from the Americas or from Europe. So there's a gentleman called John Lout. He is a professor in Tennessee University. And he says Americans born in 1960s or thereabouts are responsible for 1 or 2 deaths every year because of global warming. Westerners are responsible for reduction of lifespan by X number of years because of their consumption patterns. So Americans use per capita 19 tons. We use 1.9 tons. Germany uses 8.1 or emits 8.1 tons of CO2 in a year. We don't want to be Americans. We have to ensure that because of everything that we're doing, we make it a better place to live in for the generations to come. Thank you very much for your time, and we look forward to further interactions during the day. Bye now. Thank you, sir, for your time. Much appreciated. Thank you, sir.
Thank you so much. That was indeed an enriching discussion. Thanks to such experienced panelists and moderator. I would now like to request that Mr. Mishra kindly present the mementos to Mr. Sanjeev Gupta and Mr. Narinder Goyal, and Mr. Narinder Goyal kindly present the memento to Mr. Baroruchi Mishra. Thank you. Big round of applause. Thank you so much.